Hello. Today we'll see how we can use the horseshoe to represent another group of expressions, such as only if and unless, as well as to state necessary and sufficient conditions. So let's start with only if. By the way, you have to pay attention here. Don't confuse only if with if and only if, which we studied in our previous video. To know how to symbolize a given expression in SL, we use a truth table. We're going to do that with only if. An example is you will join the club only if you become friends with Al. The two components are the sentences you join the club and you become friends with Al. Let's see what happens to the whole sentence depending on the truth values of the component sentences. Let's begin with the first row. There's no reason to think that the sentence is false, so let's make it true. Now the second row. You join the club is true, but you become friends with Al, it's false. This means that you can actually join the club without becoming friends with Al. And so the condition expressed by you will join the club only if you become friends with Al is false. In fact, this is the only situation in which the sentence comes out false. Let's go to the fourth row. If you don't become friends with Al and you don't join the club, well, this agrees with the rule that says that the only way to join the club is to become friends with Al, so we make it true. Row 3 is the trickiest one. This is the case in which you become friends with Al, but you don't join the club. It might seem, on first impressions, that this makes the whole sentence false, but it doesn't, really. Notice that what the sentence says is that if you don't become friends with Al, you won't join the club. It doesn't say that by becoming friends with Al, you automatically get club membership. Perhaps you happen to like Al, but have no interest in becoming a club member. Or perhaps becoming friends with Al is not the only condition. Perhaps you also have to become friends with Sally to become a member. So that if you fail to become friends with either Al or Sally, then there's no chance of you becoming a member of the club. So there's no reason to make it false. And in the absence of such reason, we'll make it true. And this applies in general to sentences of the form X only if Y. They are only false when X is true and Y is false, and are true otherwise. And this makes sense, given that Y is supposedly giving you the condition without which X cannot be true. So if X is true without Y also being true, then it is not the case that X only if Y. Now, let's look at the same truth table again, the one that we made for X only if Y. It happens to be identical to that of a connective we've already studied. Do you remember which one it is? Think about it for a second. Yes, the truth table is identical to that of the horseshoe. So X only if Y is equivalent to if X then Y, meaning that whenever one of those sentences is true, the other one is true as well. And whenever one of them is false, the other one will also be false. So they are logically equivalent. Moreover, if X then Y is also equivalent to if not Y, then not X. This can be seen in this other truth table. To the right of if X then Y, we have if not Y, then not X. I've already filled the truth values for the antecedent and the consequent, but not for the conditional itself. We'll place these values under the horseshoe. So if you want, pause the video so you can complete the table yourself. Okay, once we have filled the truth table, we can see that no matter which case we consider, they always have the same truth value, and this means that they are equivalent. In consequence, we can see that there are two ways of expressing X only if Y, and those are if X then Y and if not Y then not X. A related pair of notions is that of necessary and sufficient conditions. When we say that X is a sufficient condition for Y, what we mean is that if X obtains, then Y obtains as well. On the other hand, when we say that X is a necessary condition for Y, what we are saying is that if X does not obtain, then Y does not obtain either. So let's test our understanding of these notions. Let's begin with A. Is being single a sufficient condition or a necessary condition for being a bachelor? Well, clearly not a sufficient condition, because you can be single without being a bachelor. Suppose that you're not male, for instance. However, it is a necessary condition for being a bachelor because nobody who isn't single can be a bachelor. Consider B, where we can see the opposite is the case here. Having been born in Salt Lake City is a sufficient condition for being a Utah, because by being born in Salt Lake, you automatically qualify as having been born in Utah. However, it is not a necessary condition because you can be born in Utah without having been born in Salt Lake. You might have been born in Provo, for instance. Now consider this. Being a natural number greater than 1 that has no positive divisors other than 1 and itself is a gap for being a prime number. Here we should fill the gap by saying that it is a necessary and sufficient condition. If you have a number that is greater than 1 and has no positive divisors other than 1 and itself, then that is sufficient to qualify as a prime. It is also a necessary condition. If a number lacks even one of these two conditions, then it cannot be considered a prime number. Okay, now I ask you, which of these truth tables corresponds to the form X is a sufficient condition for Y? Suppose that X is you bribe Al and Y is you get your diploma. I'll let you think about it for a second. Let's focus on the rows in which we get false. In the first table, it is the second row. And in the second table, it is the third row. Saying that bribing Al is a sufficient condition for getting your diploma is the same as saying that by bribing Al, you automatically get the diploma. And what is ruled out is that you bribe Al but don't get the diploma. So it should be false in the case where X is true and Y is false. And that is what happens in the second row. But notice that the table we end up with is the same as the one for the conditional. So we can see that X is a sufficient condition for Y is equivalent to X horseshoe Y. The other table corresponds to X is a necessary condition for Y. Suppose that X stands for you befriend Al and Y stands for you join the club. So befriending Al, which is X, is a necessary condition for joining the club. So it's false that you can join the club without befriending Al. So the case in which this sentence is false is that in which you join the club but do not befriend Al. That is the case in which Y is true but X is false, which is precisely what you get here. So X is a necessary condition for Y is equivalent to if Y, then X. Now, as this table shows, Y horseshoe X is equivalent to not X horseshoe not Y. So this gives us another way of expressing X is a necessary condition for Y. Another construction that can be symbolized with a conditional is unless, as in, you will die unless you undergo surgery. The SL symbolization has a conditional, and we know that there's also a negation somewhere in the sentence. Where is it? Is it as in A, you will die if you don't undergo surgery? Or as in B, you won't die if you undergo surgery? It is definitely as in A. When you're told you will die unless you undergo surgery, you're not being promised that undergoing surgery guarantees survival. Rather, you're being told something more serious, namely that you're not undergoing surgery guarantees that you won't survive. What the doctor, suppose that it's a doctor saying this, then what the doctor means is that undergoing surgery will give you a fighting chance. This means that if the doctor says you will die unless you undergo surgery, then you actually undergo surgery, but also die, then your family will have no grounds for suing the doctor. Thus, you will die unless you undergo surgery is understood as you will die if you don't undergo surgery. That is, if you don't get surgery, then you die. Let us translate you will die unless you undergo surgery into a cell. Suppose X is you will die and Y is you undergo surgery. Substituting X for you will die, you get this. Finally, substituting you will undergo surgery with Y, you get X unless Y, which is the form that is being instantiated. Now, in more detail, right, going from English to SL, you may start with the unless sentence. You will die unless you undergo surgery. Then you replace unless with if not. Notice that here the antecedent occurs after the consequent. And remember that the antecedent is a sentence that occurs after if. So to prepare the sentence for the SL format, we can put the antecedent in the place in which it would be in a conditional SL sentence, namely at the beginning. Then, you don't undergo surgery in sentential logic keys is, it is not the case that you undergo surgery. Now we have an if-then construction, which we can replace with a horseshoe. And we can exchange it's not the case with a tilde. Finally, we can substitute the atomic sentences with the sentence variables. And we reach the general form, x unless y, which is represented as if not y, then x. And this is a convention we're going to adopt from now on. X unless y is understood as x unless y. So the evaluation for unless sentences is this. You will die unless you undergo surgery is only false when you undergo surgery is false and you will die is false. Remember that what the sentence expresses is that you're not undergoing surgery guarantees that you will die. Thus, if you undergo surgery is false and you will die is false, then the sentence is false. Also, if you undergo surgery is false and you die is true, the doctor's dire prediction has come true. And so you can't say that they have lied. We owe them a true in this case. Now, it's crucial to notice that the statement doesn't say anything at all about what happens if you do undergo surgery. For all the sentence says, it is still possible that you will die even if you underwent surgery. But the surgery at least gives you a chance of surviving, which you wouldn't have if you didn't undergo surgery. So, if both you undergo surgery and you die are true, then we have no real grounds for saying that the doctor was lying. So if you're going to give it a truth value, which is what we have to do, that value shouldn't be false. Let's make it true then. Finally, if you undergo surgery is true and you die is false, there is absolutely nothing here that falsifies the doctor's statement. So it also gets T. So this is the truth table for X unless Y. The only row where we get an F is the final one, with 2 Fs. And so we can see, if you need to pause the video to think this through, please do it, that X unless Y has the same truth table as if not Y, then not X, which supports our practice to treat both as equivalent. Finally, truth tables reveal that there is another form that is equivalent to X unless Y, and that is XVY. So instead of saying you will die unless you undergo surgery, the doctor might have said either you undergo surgery or you die. Here we are saying that both disjuncts cannot be false at the same time. At least one has to be true, which actually is the same as what was being said with the unless formulation. So there are these two equivalent forms for symbolizing unless. One is if not Y then X, and the other one is X or Y. Okay, that's all for today. Bye.